Hello everyone, this is the first lesson recording for IM1, April 27, 2021. We begin with just looking at these three bunnies and see if you can tell which one is the different one. See if you can tell and tell me in private chat. Some announcements. Quiz number 5 is going to be next class, and it's going to be covering transformation, that is translation, reflection, and rotation. So you should be able to recognize translation, rotation, and reflection, effects of transformation on figure size, shape, and orientation, and describe the transformation fully. Okay, well, depending on whether it's translation, reflection, or rotation, they all have very different requirements. And also the prime notation, the ABCD transform to A prime, B prime, C prime, D prime, as well as the translation rule notation. So if you have x comma y becoming x plus 5, y minus 3. What does this relate? What does this mean in your images, in your diagram, visually? And also the equation of vertical and horizontal diagonal lines. So you should be very comfortable with homework number 22, 23, 24, and 25. Goal for the day. We are going to be covering symmetry, like reflection symmetry and rotation symmetry, and then finally we're going to finish up with the perpendicular lines. So let's talk about reflection. Okay, let's go back to reflection. If I reflect T over the red line, what happens? What happens? Okay, if I reflect this over this red line, what do you think would happen? It's the same image. So let me show you that. Okay, so if you have this image here, and if I was to get my mirror, this is a mirror. If I was to put this right there, do you see that it creates the same image? Depending on the angle that I put it in, it creates the T just through the reflection, just as you've done here. Okay? Or another way of looking at it is I could have just traced this, and if I folded it in half, is there a way that I can fold in such way it is right on top of the other? Okay, that's what I did here. Okay, so when that happens, we call that the image has a reflection symmetry. And to describe that further, I'm going to show you a quick resource page. And these notes are from mathisfun.com. And when you click reflection image, this is what you get. And you can see that the left and right, they perfectly match, right? So here we say that this image has a reflection image, and it can be, the line of symmetry can be horizontal as well, and the top and bottom is a reflection. If I flip that image right over here, it will match perfectly, okay? And the line of symmetry can be horizontal or vertical, and here you see a whole lot of images with reflection symmetry. Notice that this sample artwork, it has a line of reflection right on the red, and the top and the bottom is exact reflection of it. So we say that this has a reflection symmetry, this image has a reflection symmetry, and so on. Okay, so they all have reflection symmetry because when you actually fold them in half, it matches up exactly. Or if you put a mirror right in the middle, you can create a reflected image exactly. So now you're going to be working on card number 1 to 6 of Desmos. It should be relatively quick. So card number 1. Does this image, the arrow, have reflection symmetry? If yes, draw in the line of reflection. That means, is there a line in such, if I fold it in half, that it will be right on top of it, the image would match up? Okay, or if I put a mirror in some direction, that it will create a reflected image perfectly that matches up the other side. Okay, so here I have that same image, and of course I can rotate it anyway. If I have it like this now, and if I made a tracing of it and cut it out, is there a way I could fold it in such that it matches up precisely? If I fold it like this, does it match up? No, the images don't match up. Okay, but if I fold the shape along here, it falls exactly, right? It disappears. All the lines disappear. So it falls exactly. So this is like saying that that is my line of reflection. So I am going to draw just that. And I can also use a mirror to demonstrate just that. If I have this image here, if I put my mirror right here, do you see that I just created that same image from the mirror reflection? If I do it like this, it does not create the same image, okay? But if I have the line of reflection looking like this, it does. Okay, and the next image, card number 2, is this one. Can I create a line of reflection such that I can create the same image over the mirror? Yes, I can do so in many different lines. Okay, so there are multiple lines that I can do that. And I can also show you how that will look. Okay, so if I have a copy of the image, if I have a cutout of the image, like here, okay, so it is an exact match. Can I fold this in such way that all the parts match exactly? Yes. Or, so I can join the vertices, and those fold lines represent the way line of reflection in such way the shape maps right on top of each other when I fold it in half. Okay, I can also fold it this way and this way and this way. So how many different lines do I have? I have 1, 2, 3, 4, 5, 6, 7, 6. I have 6 lines all together. Okay, so again, it's really the number of lines it can create. So you can say that this has 6 different lines of reflection. Alright, so then card number 3. What was card number 3? Desmos card number 3 was this shape. Okay, does it have reflection symmetry? Well, if I use the mirror, can you create the same image through the mirror in any way? No matter what I do, I cannot create the same image. And I can demonstrate that with this. Well, no, actually, I'm going to move on. What about this? Can I create the shape with the mirror by reflecting it? Okay, there you go. There's one. Is it the only one? There's another. There's another, and so on. There are many lines of reflection that could create the same image when it is reflected. Okay, so yes, it does have line of reflection, and it also has reflection symmetry. What about this one? Okay, can I create the same image if I reflected it like this? No, that just gives me the same shape. Or if I reflect it like this, that's not right either. Is there a way? Well, if I do it like this, yes, it does create the line of reflection. With this shape, some of you might have said no. I don't know if any of you actually checked precisely. So what we are claiming is that if you have this shape here, okay, so I have made a cutout of this. If I fold it, where is the line of reflection? Line of reflection is right here. Okay, so if I fold it in half, like so, it should disappear exactly, right? Well, it so turns out that this length is just slightly, ever so slightly longer. And do you see that there's extra bit here? So it doesn't match up exactly. So some of you might have said that, if you notice that, you might have said that, no, it does not fit. Okay, but otherwise, well, assume that this is the same length and it was meant to be the same length, then you could say that this shape has line of symmetry or reflection symmetry. What about this shape? Can I put my mirror in such way that I could create the same image with the mirror? Now if I reflect it here, I create an F, not a Z. If I reflect it here, I create what looks like a triangle kind of looking thing, or rhombus. Okay? If I reflect it here, I create an arrow. If I reflect it here, I create what looks like a, I don't know, wine glass or something. Okay? So no, this image does not have reflection symmetry. Now that we've talked about reflection symmetry, we're going to talk about rotational symmetry. And to consider that, I'm going to show you this website. Again, it's from Math is Fun on rotation symmetry. Rotational symmetry, a shape has rotation symmetry when it still looks the same after some rotation, or less than 1 full turn. Okay, so 1 full turn, any image is going to have, when you reflect 1 full turn, 360 degrees, it's going to be match up exactly. However, we want more than 1. Okay, so looking at this shape here, okay, if I was to play this, do you see that it is moving once and then twice? Okay, so this this notch here marks the top, and when I turn this shape 180 degrees, there it matches up exactly, and then on another 180 degrees it matches up exactly. So we say that the order of reflection symmetry, or the number of reflection symmetry within the 300 degree is 2 here. What about this shape? If I was to rotate it, it will look like this. Once and twice, and this is the full revolution or full turn. Okay, so 360 degrees, and so we were able to match it up 3 times within a full circle or full revolution. So we say that the order of rotational it does have rotational symmetry, and that order is 3. Okay, so how many times it matches as we go once around the whole revolution is called the order. Okay, so there are here, these are order of 2. Okay, these have a symmetry with order of 2, because if you turn it once 180 degrees, it matches up, and if you turn it again, it matches again. So this is an artwork that has order of 2 symmetry. This has order of 3 because you can match it 3 times. What about this? You can match it 4 times. And this one has order of 8 because you can match it 8 times within 1 full revolution. So considering this shape, okay, I've marked the top as with the blue dot to make sure that we know when we've reached the full revolution or full turn. Okay, so the order of rotational symmetry is the number of times the figure is the same while making the full 360 turn. So I can turn it once and it matches exactly, and 2, 3, 4, and 5 times we're back to where we started. Okay, so within 1 full turn, it matches 5 times. So we say that the order of rotation is 5. It has a rotational symmetry, but on top of that, the order of rotation is 5. Okay, so looking at this, what do you think is, do we have rotational symmetry? And if so, what is the number of, or what is the order of rotation? Well, for that, I can trace it and rotate it. Okay, so here we go. I've made a tracing of the image, and I've also marked it with a red arrow to indicate where the top is. Okay, so then I can start turning it. Okay, turning it around the center and until it matches exactly. Oops. Keeps on moving on me. There you go. It matches once. And then keep turning it until it matches exactly. Here we go. There is another. And here we go. It's the 3 times. Okay. I'm going to continue with the next